Right, function notation now for you. This is often a confusing topic, but actually it's a really, really straightforward topic. I think just the two words function and notation can end up being a bit confusing, and just the way it's written. But go through these slides a couple of times, and it is actually really straightforward. Okay, when we talk about a function, it's basically just what we've always done. Okay, just what we do in terms of equations. But what it means is that we have a set of inputs, in other words, mathematical operations. So adding, subtracting, multiplying, dividing, square rooting. There's a bit of trigonometry involved, squaring stuff, cubing stuff, all the different things that we can do mathematically is built up, and when we want to do multiple of them, it basically forms a function. So if we want to take a number and we want to multiply it by another number and then add something to it, we'd have a function. So something like this is basically a function, but the way we write it from now on would be like this. And this is what we call function notation. So you see this f bracket e x bracket e equal 3x plus 1. That's what we mean when we talk about function notation. Don't be put off by it, okay? It's the same idea. We've written kind of equations as y equals, or a letter equals 3x plus 1. But now we're just going to write it as f of x equals 3x plus 1. Right? We can write it as g of x equals 3x plus 1. It's not just f, but because it's a function, we often start with f. But in the same way that we can use different letters other than x, we can use different letters other than f. This is just the most common one that you'll see. Right, it's pronounced, and you don't say f bracket x bracket equals 3x plus 1. It means f of x. Okay, so if it was a g, it would be g of x. It's the function of x. So it's x is changing. However, the function that we apply to it, the mathematical operations that we apply to it stay the same. Okay, and that's all you really need to know. And at the end of the day, this is just going to be substitution. We've done lots of substitution before, and I'll explain it in more detail on the next slide. Okay. So that's kind of an explanation for those of you that can't listen. But the main reason for wanting it is that it can often get confusing when we're dealing with multiple different functions. Okay, so if on a graph, for example, we had lots of different functions and they were all y equals, that might lead to some confusion later on. Okay, so although it is y equals, and because on a graph it is x and a y, we just need a different way of representing this, and we do that through function notation. So if we wanted to graph on the same set of axes 3x plus 1 and say a half x minus 7, okay, we might have those two functions as f of x equals 3x plus 1 and g of x equal to half x minus 7, just to save that little bit of confusion. Okay, I know most of you won't think that's confusing, but later on it can get a little bit confusing. Okay. We're not necessarily going to be doing much in terms of graphing this just now. It will come out later on though, and it's just denoting, it's just showing you that there's just different functions with different inputs. Okay. But all we're going to do at this stage is we're basically going to find different specific values within that function. In other words, if it was represented like this, y equals 3x plus 1, and we knew one or the other, we could find the other by solving that equation. Okay, it's going to be the same kind of idea. As I say, it's just going to look different. But at the end of the day, all we're doing is we're solving equations in the same way that we always have done. Okay, so I'm going to go through this, and hopefully this will show you exactly what we mean by function notation and exactly how it works. So I'm taking this function. This is a function that we're given, f of x equals 2x plus 7. In other words, the function of x is basically 2 times by x, and then we add on a 7. So if we wanted to do something, we could, with our x, we'd times it by 2 and we'd add on 7. Okay. What we're going to look at, as I say, this is a slightly different notation as well. But what you're going to be asked in the question is perhaps to find f of 3. Right. All that's happened here is in our function, the x has been taken out and a 3 has been put in its place. So we're still dealing with that same function. Okay. We've still got f of x. It's equal to 2 times by our x plus 7. But if we wanted to find f of 3, the x comes out, or the x has come out, and a 3 has been put in its place. So on the right-hand side, in our actual equation part, we do exactly the same thing. We take the x out, and we replace it with a 3. Now we have something that we can simplify. Okay, 2 times by x plus 7 is simplified as just 2x plus 7. But if we took out that x and replaced it with a 3, we can find this out as a singular number. And that's all we're going to do. So we're just going to work this through. 2 times by 3 is just 6. Add on the 7 is 13. So f of 3 is 13. In other words, all that's happened is in our original function, x has been taken out and a 3 has been put in its place, and we've just worked it through. So similarly, if you wanted to find f of minus 2, okay, all that's going to happen in our original function, we've got f of x equals 2 times by x plus 7, exactly the same as what we had before, okay, but the x is going to come out, and a minus 2 is going to go in its place. And now we can simplify this, and we can work out what f of minus 2 is equal. It's 2 times by minus 2, and then add on 7. 2 minus 2's is minus 4, add on 7 is just 3. So f of minus 2 is just 3, okay? Similarly, if we had f of anything, okay, I'm just using a for anything just now, exactly the same thing applies. Okay, we stick with our first function. We've got f of x equals 2 times by whatever our x is, and then plus 7. X is now changed to an a, so it's 2 times by a plus 7. And all we can really do with that is 2 times by a plus 7. Simplest form, 2a plus 7. Okay. But the second part of a lot of these questions, and this is going to be a question, this could be a question in your exam, just f of x is 2x plus 7, find f of 3. But you could also be asked as a part B, something like this, to do with f of a. Okay, so I'm going to focus on this a little bit. Okay, and what we basically could be asked at part B is that if f of a equals 19, what does a equals? And this is kind of the reverse of what we've just done. We found that f of 3, if you look back at what we had, f of 3 equals 13, f of minus 2 equals 3. What we're going to look at now is basically what number did we put in the same way that we put 3 and minus 2 in to give us 13 and 3. What number did we put in to give us an answer this time of 19? Okay, and all that happens here is we set up an equation. Okay, we've got 2a plus 7 equals 19. So 2 times by something and then add on 7 gives us an answer of 19. And that's all just denoted in this form. And that's why we use it. It's just a simpler way of kind of saying something that might require a full sentence. But all we've got now is we've got an equation. 2a plus 7 equals 19. And what we can do with equations is we can solve them. 2a plus 7 equals 19. Take away 7 from both sides, and we get 2a equals 12. Divide both sides by 2, and we get a equals 6. In other words, the number that we put into the original function to give us an answer of 19 was 6. 2 times by 6 is 12, add on 7 gives us 19. Okay, and that's kind of your two stages of this question. Okay, right, so if you're copying this in your notes, these are the kind of things I want you to look at. So given the function f of x equals 5x minus 12, find part A, f of 9, and part B, p, when f of p equals minus 32. Right, it's confusing to read, it's confusing to understand, but it is just substitution. Okay, so what this one is saying, and you can see by what's happened here, that x has been replaced by a 9. So on the right hand side, we're just going to replace the x with a 9. And we're going to work it through. 5 times by 9 minus 12, what does that give us? 5 9s are 45, take away 12, it's 33. So f of 9 is just 33, and it's as simple as that. It's just a simpler way of writing substitution. So the second part is often a little bit more confusing. P when f of p equals minus 32. But all that's happened here, if we look at it closely, what's happened is that x has been replaced by a p. So we're going to replace the x with a p. And what happens when we do that is we get an answer of minus 32. So start with the original equation because it's still based around this one. But f of p is equal to 5p minus 12. We can't do anything with that unless we know what it equals. And from the question, we do know what it equals. It equals minus 32. Now we have an equation in the same way that I had before that we can solve. If 5p minus 12 equals minus 32, go through the same stages, don't try and take any shortcuts. What we want to do is basically solve it for p, in which case we need to isolate the p, get it by itself. So start by adding 12 to both sides. When we do that, we get 5p equals minus 20. Just be careful with negatives and things here. And then to find p, we need to divide both sides by 5, in which case we get p equals minus 4. And that's it. All this is saying is just a simpler way of writing what number did we put into this function, okay? What did we replace x with to give us an answer of minus 32, okay? And it's just working it backwards. In other words, it's solving an equation. Right, that's the more basic end of these equations, these kind of questions. But then this one is a little bit more complicated, okay? It's complicated because it's got the x squared, okay? We can deal with that though, but there's just one little thing at the end of all this that you're going to need to really watch out for, okay? But just go through it as normal. G of x equals 2x squared plus 1, find g of 12. In other words, x has been replaced with 12, so I'm going to replace the x with a 12. G of 12 equals 2 times by 12 squared plus 1. Be careful with the order here, okay? Remember, it's BIDMAS, in which case your indices come before your multiplications, in which case I need to do 12 squared before I multiply by 2. So don't do 2 times by 12 and then square it. This is very specifically 12 squared and then multiplied by 2. 12 squared is 144. If we times that by 2, I get 288. And if I add 1, I get 289. Okay, so they're not anything too different. There's a squared in there, so it's a little bit more complicated. Okay, but that's the same idea as what we had before. We've got a function. We're going to take the x out. We're going to replace it with a number. We're going to find a solution. In the second part, part B, what's happened is we've taken the number out, we don't know what it was, but we got an answer of 19. In the same way that we took out the x and replaced it with 12, we got an answer of 289 here. We want to find out what we took out, or what we put in place of x, to give us an answer of 19, okay? So just read it carefully. G of a equals 19. The x has come out, it's been replaced by an a, so g of a equals 2 times by a squared plus 1, and we know that that's equal to 19. So what we've got here is we've got an equation, and we can solve this equation, but there's just one slight thing that you need to be careful of. Okay, but just go through it as normal. 2a squared plus 1 equals 19. Start by taking away 1 from both sides. In other words, 2a squared will equal 18. Divide both sides by 2. A squared will equal 9. And at this stage, if you know that a squared equals 9, you want to find the square root of 9 to give you a. Okay, and this is where you need to be careful, because yes, you may think it's a equals 3, okay, but it's not just a equals 3, okay? Square root of 9 is technically 3, and it is minus 3. Okay, so you need to be very, very careful. Basically, what we're doing here is we're trying to find out what number we put in place of x to give us a number of 19. So yes, we could have put 3 in, okay? 3 squared is 9, times by 2 is 18, plus 1 is 19. That is true, but there could be other solutions as well. Right, minus 3, if we put it in place of our x, minus 3 squared is also 9. Times that by 2, 18 plus 1 is 19. So there's two possible solutions here. It's two possible numbers that we put in place of our x to give us an answer of 19. Right, this will only really happen when you've got a squared term. Okay, there are other ways, perhaps better ways of doing this, but we haven't really looked at them yet, but I will look at them later. But the bottom line is, if you square rooting 9, and we have looked at this before, the square root of 9 is 3 and it's minus 3. And you have to write both of these down to be able to get the full marks for a question like this. You don't have to write it as 3 or minus 3. You can write it as plus or minus 3. Okay, so the little symbol plus on top of a minus. But you have to have them both to get the full marks. Okay, but that's generally what function notation is about. There's not much more to it than that. As I say, it's a different way of writing things. I know it's another way of writing things that you probably think it's not necessarily appropriate, but there's going to be more uses for it later on. Okay, so don't be put off by it. Just read the questions carefully, look at what's going on. Okay, with these ones, the x was replaced with a 12. So on this side, replace the x with a 12. Here, the x was replaced with an a, and I knew that when I did that, I'd get an answer of 19. So just work it through and just kind of think about the questions as you do.